What? Okay.
You're free to start whenever. Whenever you're ready.
All right. Good afternoon, everyone. Thank you all for coming. Today I would like to introduce you to Angular. First, I would like to introduce myself. My name is Konstantin and I am from Germany. I've came to Japan 2 months ago to join Code Chrysalis. Prior to that, I have been in a long-term internship at a small tech company near Hamburg. And I've been into tech for quite a while now, and I have decided that after high school I would try to pursue this professionally, and combined with plans that I had to study abroad, I have found Code Chrysalis and now I'm here. These are my socials, and that's me. And yeah, now let's get into Angular, starting with some general information. So what is Angular? Angular is a web-based front-end framework that was released in 2016 under the name of Angular 2 as the successor to Angular.js. And although the names are pretty similar, they don't have really anything, or at least not much, in common besides the name. It was originally developed by Google and released as an open source project, so now it also has many contributors from the open source community. And as of May 2019, they have around 48,000 stars on GitHub. And actually, according to the Stack Overflow Developer Survey of 2018 and 2019, it was voted to be the second most professionally used technology. And yeah, what does Angular do? So basically, it's a framework to create single page applications that aim to provide native mobile and desktop experience. All right, so now you might think, oh no, wait. Let's first talk about what a framework is. Let's start with talking about what a library is. So a library is basically a piece of functionality that you can use in your project pretty much everywhere you want. And a framework is really similar to that, except that a framework is more opinionated and more strict. So it is the framework that decides where you can use things and not you. Alright, now that it's out of the way, you might think, okay, so what is it? Just another framework? Well, yes, kind of, but there are many things that actually make Angular better compared to other solutions. And on a quick note, when referring to competitors in this talk, I am referring to React and Vue.js. All right, then let's see what makes Angular so good. First of all, is it just works. But what do I mean by that? So Angular comes with a lot of functionality. For example, the Angular CLI, command line interface, which comes with many functionalities that improve the quality of life for developers. The CLI of Angular is very advanced, so you can do many things, like for example, generating a complete Hello World project that works just like that, and create new building blocks for the application. And it also has a built-in development server with hot reloading and many other things that are again gonna improve your quality of life. And yeah, there are many built-in tools. So when you try to create a complete project on the complete front-end project, there are many tools and functionalities that you're going to need to make it beyond the basic level. These tools include Redux, or for example, a client-side routing system, or or an HTTP client. Yeah. And Angular comes actually with all of these things out of the box. And this is only a small part of what Angular supports. So yeah, that's very helpful. And the next thing is it has native support for many style extensions such as CSS and Sass, also out of the box. And yeah, another thing, probably one of the most important things that makes Angular good, is TypeScript. But what's TypeScript? So TypeScript is a subset of JavaScript with extended functionality. So it was created by Microsoft, and what it essentially is JavaScript with a C#-like syntax. And what that means is that it also supports many new functionalities, such as lambdas, which JavaScript kind of supports out of the box too, but it's a little bit different with TypeScript. Interfaces, and most importantly, static type checking and compile time errors. And why these are the most important is because it often happens that while writing code, you create small, silly or bugs that could be easily prevented. Especially in JavaScript, where there is like so much freedom for you that you can't know when you mess up somewhere sometimes. But with TypeScript, there is static type checking and compile time errors. So when there is something that you accidentally forget to add, it's going to tell you. And although the application still works even with these errors inside them, knowing about these errors is very helpful. And yeah, it also supports plain JavaScript. So if you wanted to, you could use Angular with plain JavaScript, although it's not recommended, just because of all the new functionality that TypeScript has to offer. All right. Another reason why I think that Angular is good is that because it's a framework and because of the usage of TypeScript, you are kind of forced to write higher quality code than usual, just because of the reason that it's so strict. And the result of higher quality code, most of the time at least, is easier to maintain and easier to expand projects. But that's not all. Another reason why, or like if you follow the guidelines that Angular provides to you and the guidelines that TypeScript provides to you, it's easier to for developers that are new to your project to get into it, because if everyone follows the same rules, it's going to be obviously easier. Yeah. And as most things in programming, you should always try to aim to make code that is reusable as much as possible. And at last we have security. So Angular is a pretty new framework and it's backed by Google, so you would expect that it's going to be around for at least a couple more years. However, there are some things that I believe make it even more secure than you might think at first glance. Which is, for one, it's used by many big companies. Some of these companies are, for example, obviously Google with YouTube TV, and actually one of their most important projects, which is Google Ads. And Microsoft also uses Angular for their web-based Xbox store. And Forbes also uses it for their website. There's actually a website that provides you with a lot of pages that were made with either Angular or AngularJS, and you can check which companies have done which projects using that technology. Yeah, and one more thing, why I believe that Angular does or might have a bright future ahead is the planned Ivy render engine. And why I believe that this is a big thing is because from what they have announced so far, it's going to improve the performance to what I've previously mentioned, to maybe native mobile and native desktop performance. But what is the Ivy render engine? So the Ivy render engine is their engine that they use to detect changes in the project to update the DOM. And yeah, many other technologies and frameworks and libraries, of course, use technologies like these. However, Ivy render engine has some functionality that they claim to be very efficient, so that the memory footprint is very low, which is of course important for native mobile experience. But also what they have not only announced but also already provided is proof that this new engine makes it possible to decrease the bundle size of a project by a lot. So a few days ago the new Angular 8 was released, and with it they have made a comparison of the most basic bundled Hello World application in comparison to the most compressed one. And the result was going from 150 kilobytes of an Hello World project to just 14. And although the Ivy render engine is not yet publicly available, at least not fully, there was a preview coming out with Angular 8. It is planned for quite some time now, so it should be available not so long from now. And yeah, I believe that if they actually manage to achieve what they have promised, then this is a big step for Angular. Alright, now that we all know that Angular is the best framework in existence, let's go more into technical details about how the project is actually built, starting with the project structure. So the most basic Angular project consists of modules, components, and services. Modules are important, but they have no logic. It's just a container for stuff, basically. And components is probably the most important thing of the project, because that's where the HTML and the CSS lives, and it's what the user is going to see. And then we have services, which is the behind-the-scenes logic, which it's like the back end for the front end framework. And Angular is actually following the single responsibility principle, like most technologies nowadays, which means that you shouldn't have a single component have different parts in it. So a single component shouldn't have a header, a footer, and a content, but each of these should be separated into a single component. So header component, content component, or footer component. And the same goes for services, of course. Alright, then let's get more into detail about these different things, starting with the components. So, as I said before, components are the view part of the application, so what the user is going to see. It can be generated with the following CLI command, and what it generates is a HTML file, plain HTML, nothing special, and a CSS file. It also looks like it's nothing special, but it's encapsulated, and what that means I'm going to explain a little later. And then it generates a TypeScript class that is also part of that component, and there all the UI's logic is handled. And at last we have basic tests. So everything that you generate with the Angular CLI is gonna come with basic tests using the Jasmine framework. So starting with the view part of the component, which is the HTML and the CSS. At first glance, it's just normal HTML and CSS, but it actually comes with some functionality that expands the usual functionality that you know from HTML. Like, for example, directives. So directives are special HTML tags that, again, can expand the functionality that you have. Like, for example, ngIf, ng stands for Angular, and what it does is it renders a component based on a condition. And then there's ng4, which repeatedly renders a component also based on a condition. There are many other built-in directives, but these are probably the easiest ones to understand and the ones that you will use the most. And yeah, and then we have interpolation. So a component, every single file in a component is connected with each other. So that means if you create a variable in the TypeScript file of the component, you can actually display the value of that variable within the HTML by using interpolation, which looks like this. You just have to put the name of the variable within two curly braces, and it shows up. And you can use it anywhere. You can show it within a paragraph, a header, or inline HTML, like for example in the style like width or something. Yeah, and then at last we have pipes. If you have ever used a command line, you would like, it works basically the same. So pipes work that you take the output of something and pipe it to another function using the I don't know how that thing is called, but it's like, yeah, and like that you can pipe the output of the left side to the function on the right side, and the output of the right side will then be shown on screen. And yeah, so for example, if value equals to hello, and we are gonna pipe that value of hello to the uppercase function, the end result will be hello in all uppercase. And yeah, about style encapsulation that I've mentioned earlier, what that means is that if you have different components that have style sheets that contain same class names or IDs or something, it's not gonna clash, I guess, because a CSS is only valid for the component that it's a part of, which I think is pretty useful. Alright, now let's get to the TypeScript file, the presentation logic, which is a single TypeScript file with a component class where all the logic is handled. And another part of the TypeScript file is the decorator. What that means is unimportant now. It's some TypeScript thing, but what we need to know is that it defines metadata. And in the case of a component, the metadata that it defines is the path to the HTML and the CSS file, as well as the locator. And the locator is basically just a HTML tag that you use to import this component somewhere else in the project. Alright. And as mentioned before, it handles the logic of the UI. Like, for example, if you push a button, it calls function X, and that moves the button 5 pixels to the right. Stuff like that. But it's also used to connect the component with the backend logic, with the services. So for example, if the service makes some calculation and the number that you get from that calculation is supposed to show up for the user on the page, the component TypeScript file is gonna take care of that and connect it. Because such calculations that don't have anything to do with the presentation logic, so nothing that the user can actually see, should not be handled in a component. Alright, this is the basic setup of a component. So in the upper part we have imports. What you can do there is you can import, of course you always have to import the functionality for a component from the Angular core. So just that it has everything it needs to be a component. But what you can also import there are, of course, services or modules or libraries or whatever you need to work with. And then we have the component decorator, which again has the selector, the HTML tag, and the template URL, and the style URLs, which are both just paths to the rest of the component. And then we have the class where all the logic is located. So what you can do here, for example, there's the title variable, which you can, for example, show in the HTML by using interpolation. But or you can do methods that I've mentioned before for the logic. But there are also lifecycle methods. And what lifecycle methods are, they are methods that the Angular framework calls during different parts of initializing a component, or of creating a component, loading a component. There are many different ones, like for example here you can see ng-init, which is being called by Angular when the component is being initialized, but there's also a lifecycle method f for when the component is being destroyed, and many other cases. All right. And then let's now get to services. So as I've mentioned before, services are the under the hood logic. And you can, of course, with the Angular CLI, generate it like this. And what you get from that is, again, a TypeScript file where, it's a class where you put all the logic that you want to. And also, again, basic tests. Yeah, so the under the hood logic. So what does that mean exactly? So as I've mentioned before, data processing, so stuff that is outside of what a user is supposed to see. So for example, HTTP requests to get data from the backend. But it's also used to share data between different components. Because services actually have, if they are implemented correctly, a single instance throughout the project. So it can be used to share data between modules, but also not only across a module, but also across different modules. Or you can use it to share functionality, like for example, a service that, a helper service that, for example, translates the response of an HTTP request into JSON or something like that. Okay. And what you have to keep in mind that these kind of operations should always be put into services, because again, the component is only for presentation logic, so stuff that does not include anything visible to the user should be done in services. All right, then let's get to the modules, which are not so cool. They are created with the following command again, and there always needs to be at least one module per project, but the module doesn't include any logic. So all that it's used for is for including things. So it's basically just a namespace with benefits. It's a container for all the functionalities, like for services, pipes, directives, and components. Okay, this is the basic. This is how a basic module looks like. So in the upper part, we have again all the imports, like for example, components or services. They all need to be imported so they can be visible throughout the whole module. But also third-party modules or modules inside the project. But different modules that are inside the project. And then again, we have this decorator, which is again used for metadata. But in this case, we have different stuff to input for the module, which is declarations, which you use to make components that are imported, or services, components, directives, and pipes, to make them visible throughout the module. So you don't have to import every single thing that you want inside the file that you're currently working on, but just in here, and it's visible for everywhere. And then we have the imports. which you can use to import, again, third-party modules or just different modules that you have inside your projects. And then we have exports, which you can use to export functionality that that are part of this module, which will then be visible throughout the whole application. And we have providers, which is used to make services visible throughout the whole application. All right. Now the question is, how does it compare? Like, are there any things that Angular does wrong? Yes, a few of them. So for one, it's not SEO friendly, at least not out of the box. So if you have worked with software search engine optimization before, you know that it's never easy. However, Angular just takes away all your chances of ever making a good search engine optimization. At least if you don't use any third-party software, which does exist, but that's of course not the best solution. And then another thing that I hear a lot is that it has a steep learning curve, which I agree with. It has a lot of functionality, and learning all of that is going to take some time. But if you compare just the basic just the basic functionality of creating components and compare them with competitors, then it's probably on the same level. Just the fact that it has so much functionality makes people believe that it's hard, which it is. But if you take, again, another, like React, for example, and bundle it with third-party libraries to get the same type of functionality that Angular has to offer, then, and learning all of that is also going to take a while, so I think it's fair, but yeah. And at last we have, although it's popular, it's used by many big corporations, it's also hated amongst developers, kind of, because according to the very same developer survey by Stack Overflow from 2018-2019, both years Angular was voted to be the 4th most dreaded technology. Yeah, that's it from me. Thank you for listening.
Thank you, Konstantin.
photos and videos and panels and stuff. So 360 photos, if you've never seen a 360 photo, that's a typical 360 photo of Dubai. And you can just stitch, traditionally you can get a camera, like a DSLR, get a tripod, and you'll just take many photos to get everything and then stitch them together in Photoshop or some other software. Although you can recently use Google Street View and do a 360 photo, but they don't turn out very well and they're not really usable for this kind of stuff. Or the best option is to get a 360 camera, which just takes it all in one shot and stitches it all together for you, makes it really easy. And if you've never seen a 360 photo, there's just a typical one. So yeah, you can just, that's Hong Kong, you can just drag them around and look everywhere, the 360 photo. Okay, so getting started with React 360, it's really easy. You just install the software. So if you're using Node, you can do npm install, and you get React 360 CLI, and you'll get your software. And if you want to create a project, just do React 360 init, the project name, and you'll get your project, a big boilerplate. You can go into your project, and then you'll see this boilerplate. And the key points of this is the client.js, which you can see here. The client.js just basically, it's your root, and it renders everything to your page. As you can see here, we've got set background and render to surface. It creates your page for you, and you import your other components and stuff. And index will be your main component, and you can bring other components in there. So index is where you do everything, and you import it into client and render it to your screen. Also, static assets are very important. That's where all your photos and videos and stuff are, and they have this get asset URL and also an asset component which will directly take you to static assets. So you need to keep static assets that name. It's all rigged up so it directly goes to that folder and gets your stuff. And then if you just run npm start to start your project, you'll see this screen. And if you go back, you can see this is the set background. The first background is a 360 world JPEG. So they give you this 360 kind of space world, and then a big panel there. And that's what you'll see when you start your project. The core components, the view is probably the most important component for your UI. It's like a div, if you've ever used HTML. It's where you put everything inside it, and you can have many views, as many children as you want inside that view, or just one view. And the text, you can't just write text in there. You have to use a text component. It's just like a paragraph, and you can style it and stuff like that. And then the VR button, this is unique to React 360. So they need a button, so they've created a button which you can access just like a normal button, but in the VR world. And entity is for models. If you're going to put 3D models and spinning objects and all that kind of stuff in, you have to go into an entity component. And the style sheet, if you use React Native, the style sheet is the same as React Native. So it's this component which you kind of create things like that. And you can see this is just a panel. You've got a width of 800, a height of 450. And you can use the flex box to move it around, move stuff around inside it. So getting a 360 image is very easy. You just open the thing you've created, you download it immediately, and just drop your 360 image name into that 360 JPEG area. You do want very large images, so they will be resized to that size, and it can take a while to load because you do need a lot of data to get the full thing. So you have to imagine you're inside like a globe, so you look around. You're basically internally a globe, and you've got one big surface, a 360 surface, where you stick your image onto it or anything else you have. So that's how easy it is. You just put your image root or name into that pick, and it will get it from the asset folder. And I'll show you a typical one. So this is the app I built with it, and you can see you've got your image, a 360 image. Anybody know where it is?
It's like Hawaii.
Yes. Yeah, somewhere in Hawaii. So there you are. So that's your typical 360 image. And most of the images I got from this thing were from Mapio.app and Flickr, and also airpano.com. So changing a background image is very easy. You have the onload image, just which comes with the CLI you downloaded, and changing the background image, to get multiple images, you can just go into your index.js and just run a set background in there. So you import your environment and then do the set background and pass your image name in, and the asset will take you straight to your assets folder. And then you can call this function and it will change your image. So hopefully when I click a button, it should call that function and change an image. Any preference?
Australia.
Sorry?
Australia.
Australia. Okay, we'll get Australia. There you are. There's the Great Barrier Reef down there in Australia. And you've got some information there. Okay, so that works properly. So that's a VR button. It's a special button. It has, it's for interacting inside it. It has no styling, so you do have to style it. It won't appear unless you add styling to it. And it will update your state, so it will update everything which is on the screen. When you press it, just like you saw, it updated the photo, and then it should update the information. So let's go to, we'll try UAE. And there you are, it's updated your information. So yeah, that's the VR button. And here's a VR button I made. You've just got your styles, and on enter, on exit, so it just changes. The important bit is the on click. So when you click that, it'll update your state and get everything. And if you've used React, you probably know some of this stuff. But it's just basically a button. And I think the most important part with React360 are the panels, the interactive panels. And I think this is what will lead it in the future, is interacting with panels, like in the Oculus browser. When you get your panel originally, you'll get a 360 panel. Not a 360, sorry, a cylindrical panel like this. And these are all for interaction. It's just like having a web page, really. And you can put anything in it: buttons, text, components, images, links, API calls, whatever you want to do. And so yeah, you'll start with a cylindrical one. Right now, you can only get a cylindrical one in the center with React360. But if you want more panels, you can stick panels everywhere, as many panels as you want. They'll have to be flat, so you won't get this curved look. They'll just be flat. And you can stick them anywhere in your surface. And we call it the surface. So we have render to surface, which is for your panels, which is in your client.js. And here's a typical panel. So you can see at the top, this is a default surface. The default surface was a cylindrical panel, which you saw in the picture. And then you can style your panel. You can put the size. It's got a width of 1000, a height of 600, and then some color there, and the items inside it. So that gives you that panel, the basic startup panel. To create a panel, it's very, very easy. That's just a panel I created, which is in your client. You can create the panel, give it a name, info panel, and then it's a new surface. And as I said before, they can only do flat at the moment in React360, so you can only get the flat shape. You can't get the curve. And you can see I've given it a width of 350 pixels and a height of 600 pixels. And you can see you've got the two panels there. They're both flat. Yes. And you've got basically an X, Y, and I guess an R axis. So the X is like this, and it's in meters. So I've moved the panel 60 centimeters to the right on that one, and 0, which is the vertical, so it's in the center of your eye line. And you can add an extra one, which would be rotate, so you can twist your panel if you want to, like that. So you can see here, I've just put this one 60 centimeters to the right, and that one 60 centimeters to the left. That would be about the middle there. Yes, so you just render to surface with your panel. Okay, and then there's the models. I kind of dived into the models a little bit. It's a bit harder working with models. Models have a third z-axis. So with the z-axis, you've got distance between you. So with your panels, you've got rendered to surface. With the models, it's rendered to location. So you can put the model closer to you or further away from you, and put them anywhere in your globe, basically. The panels, you can only stick them. You'd have to just change their size if you want to make them look smaller and bigger. And the models, you can put anywhere you want. Right now, you can use OBJ files and MTM files. So OBJ is your object model, NTL is your material, so you can actually see something on your model instead of just a white blob. And they'll go in your static assets. Yeah, so you use render to location instead of render to surface, and it's an entity component, and there's your Z axis there. So here's a typical way to render your model. You just pick a new location. Here I've put 0, 0. 0, 0 put me directly in the middle, and then -3 puts me 3 meters further away. So I'll just show you something. So this one's some models. So here I was just playing around with the models. So here you've got 2 bitcoins spinning around. They're both actually the same size. I just put this one further away, so they are actually the same size. And actually threw an iPhone in there. And you can stick stuff anywhere. So that's just a typical way to play with models. And you've got animations and stuff. So yeah, this is how it would look with your entity. You just put your styles. This is your scale. So if you did 2, 2, 2, your model would double in size, or you can stretch your model. If you did 2, 1, 1, your model would stretch that way. You can rotate your model, and there's just your folders. So a source, I had an iPhone object and an iPhone material. That's how I created those little models. There's a picture. And there's a slightly nicer looking model of an astronaut from the Facebook site. So yeah, and another great experience with the VR stuff is the 360 video. So you've got 360 photos. You can essentially do the same thing with your video. You can see it here. This is the type of thing where you just look around. So that's your phone. When you put it on your phone, it should split, and you can use it with this thing. It's a 2-step process to make the video. You need to create the player, set it to be played, and when it renders, or your component mounts, then it will start playing when you click the button and get that page coming up. So you can give them dimensions, for example, 800 by 450 to get a nice kind of widescreen, or you can go 360 with the full 360 view, and I'll show you those. So here, this 360 should see something. Okay, there's no volume. You'll have volume as well, but there you got a typical video. That's London, and you can just look around. You got Tower Bridge, the Shard, the Thames River, and you can look around, see everywhere. So that's your full 360, and then you can place as many screens as you want, put them anywhere you want. We've got Thailand here. So there you are. You've got Wat Po in Bangkok, and if you'd like, you could put 20, 30 screens. It's up to you, whatever you want. However, it does use a lot of CPU power, and it will. It's very heavy duty on the computer. And that's the code you've got for the videos. You create your player, so you import your video module, create the player, give it a name, and then when it mounts, it will auto play when you click it. And here you are. You can just see I put that screen 0, 0 in the center, 800 pixels width, and 450 down the way. And if you want full 360, you replace that with set background video, and it will just do the whole thing. The whole thing will become your background. And of course, mobile is what we all really want to do with it. So with this thing, you can just go to the app you've created and drop this in, and stick that on, and you can get the full 360 experience. Has anybody used these before? A few people. Anybody not used them before? All right. Yes. Be careful if you've never used them before. You can get motion sickness with them. I discovered one morning.
There's something similar where
Yeah.
I feel sick immediately.
Yeah.
Oh, perfect.
Yeah. So if you've been out the night before and you decide to start playing with your app the day after, be careful with that thing. So yeah, mobile is quite easy just to make it mobile. You just install a package, a polyfill package, drop those 2 lines of code in, and it's basically good to go with your mobile. But do you know how do you press the button? Anybody know how we usually press the buttons with the VR stuff?
You focus on the button?
Yes. Do you know the name of it? Oh no. Okay. Yes. So there's a couple of things. You've got a raycaster. The raycaster is that kind of laser beam you can get, and when you look around, you can see with your laser beam. and that's great as well. You just import a package, you've got your simple raycaster, clear any raycasters and load up your raycasters, and you get your raycaster. And then when you actually want to press it, we have the gaze. So the gaze button. So you just replace all your VR buttons with gaze buttons, and like she said, you keep your laser on it and it will have a timer. So I've got here, you can see I've got a timer, duration of 2,000 milliseconds. So that's 2 seconds. And if you keep focused for 2 seconds, hopefully it will change picture and it will trigger your click handling function and it will do what you want it to do. So I've got that one there. So this is a mobile ready version. You can see if I hover, there's no button working there. If you go over, with React360, the laser, the thing, you can only see it in the panels, you can't see it outside the panels. So it only works in the panels right now. And then if we go over here, and we'll hover, let's go to grease. So if you hover, you can see there's a countdown, and you get grease. There you are. Anybody know what it is? Yes, Parthenon, I think. And then try somewhere else. There we are, Haiti. And Haiti, you've got a nice tropical resort. So that's a mobile one. So in conclusion, React360, it was great fun to work with. It was really easy to get going. You can just download it, drop a photo in, and then you've got your original version of an app, basically. I think the most important thing with it are the 2D interactive panels. I think that's why they rebranded from VR to 360, because they really want to focus on this 2D interactive panels. And you could use it for lots of things, interactive trading. If you're a stock trader, you could get multiple screens and charts up. Or for like mobile tours, if you want tours of houses, for real estate, things like that, you can go to different rooms with the photos. So I think that's where they're trying to lead with it, and where Oculus is trying to take it at the moment. It is in its infancy, this tech, and it's going to be a while, I think, before the mobile hardware will catch up to really make it a great experience in the mobiles. It's still very fun to work with, but I think it's going to take a little bit for the mobiles to catch up with the amount of energy you need to use and power. So yeah, I think that's why it is. And so that's what it looks like. And if anybody's interested, you can come up here and try it on this thing if you'd like to. So please come up if you'd like to use this and have a go. Okay, thank you.
Did you take those pictures yourself?
No, I didn't take those pictures myself. I was a photographer before, so I feel kind of bad. I should have gone out and tried it. I tried it with the mobile one, and that was a total failure. But I looked at some videos. It takes a lot of work and a lot of practice to go out there with your tripod. No.
Thank you so very much for coming. It's great to see a whole bunch of new faces, some old Codristless faces, some new faces, and we're here to spread the joy of programming a little bit at a time. So today I'm going to be talking about visualizing open data with Python and D3.js. You probably already know that, but maybe you don't know too much about me. So just a quick self-intro. My name is Ian Cameron. I am from the US. But I have lived 15 years now in Japan. That means I've lived in a lot of places, well in my case anyways. I've lived in Sendai and Fukushima, which actually comes into play here during the talk, and also Tokyo and Osaka. So I've experienced rural and urban Japan. I've also bicycled the Ohendro pilgrimage. I don't know if anybody knows what that is, but this picture is me bicycling around Shikoku. It was about 1,400 kilometers. Trip all around the island, visiting the 88 temples. And that's me at number 88, if you're good at your kanji. So I've got about 10 years experience in IT, but more soft side, more consulting, training, installations, on-site testing, that kind of thing. And I enjoy throwing things. Not today, I know everybody is safe. But I do have some hobbies that involve throwing things. I go bowling a lot, I enjoy darts, and there's a Finnish game that's really cool called Molke. If anybody is curious about that, ask me later on. So, it's all about visualizations today, right? And I find visualizations very inspiring and very powerful because words and numbers are processed. Right now you're hearing my words and they're going into your brain and you have to think about what they mean, and finally you have some sort of interpretation. But visualizations are experienced. You see a shape, you see a color, you see a size. It goes in, you have a reaction much more quickly, much more viscerally. So for an example, what is the difference between 227 and 170? What does that mean to you? You could give a percentage maybe if you thought about it for a few seconds. Maybe if I put a size to it. Maybe this square has size 227 and the other one has 170. Or maybe a more human example. Here you go. 227 kilos versus 170 kilos. So there you go. You can see the difference and you can size it up and think about it. So visualizations I found quite interesting. So that's why I thought D3. I had heard about it in being used as a visualization tool. And so I really wanted to get into it, and my first few steps, I made something like this. So it's a little small, but all this is city and population data. It's latitude, longitude, and population of a city expressed as a circle on a map. That's all it is. There's no lines defining continents, but you look at this and you know exactly what it is right away. And you can pick up some really quick and easy, pointers. Let me get my pointer out here. For example, Mexico City, I think, is that area down there. Much larger than I thought it was going to be. And of course, the major population centers of China and India are just blacked out almost entirely. So this sort of got me hooked into the D3 channel for this presentation. And so here's my process. So I knew I wanted to do visualizations, but that's the end project, right? So I had to go and get my data. I had to then get and process that data, and then I had to actually turn it into a visualization. So this is how I'm going to sort of split up my talk today. I've got my data portion, which is a discussion about open data and where you can find data. Then the second part is sort of the Python part. This is where I'm actually getting the data on my machine and processing it in preparation for the visuals, which is the D3 portion, and that'll come up last. And then at the very end, I'll have some of my examples for you. So going into open data. Open data is free, which is sort of why I used it. I don't have money to spend on getting data for my course talk. So open data is data that can be freely used, shared, and built on by anyone, anywhere, for any purpose. So open data is often put out by governments on their statistical websites. It's also put out by some private groups. And I have examples from both of those, actually. But open data can be a bit misleading. It's there, sure, but it still can be hard to find, and it can be not in context. So you might have a little bit of data there, a little bit of data here. What you really want, in the end, right, is everything on the same graph all together, and you just have to like throw it into your visualization tool. But often what we get is much less organized. It's not all together. And we'll see that here as I go into examples of how governments put out some open data. So Japanese open data. There's a government website called estat.go.jp. This has been made much better from what I understand in the last couple of years, but it has national and major regional data. It has many different ways to access that data as well. You can access things directly in a database style format, making database queries. You can use API calls to get little bits of data at a time that you want. And there's also some files, there's also some data in file formats that are open for download. And they also have an English page, which is helpful for maybe many of you. So here you go. Here's a quick shot of the English page. You can see they've got a data section. You can search by themes, different organizations, how they put it out. They also have some basic visualizations of their own on their website. I could have just shown that to you, but then I wouldn't have had to do any work. So I actually went out and got data. For my presentation, I actually did not use this website. I went straight to more local data. So I went to Fukushima Prefecture's website. They also have data of all types. Population, economic, radiation, because of the disaster that happened there in 2011. But accessibility is more of a problem here. Instead of having things in a nice big database or called from an API, you just have a bunch of files, PDF files, Excel files. Recently they have some open data files, but those are just Excel files in CSV format. And again, it's hard to get context when this year's data is in this file and another year's data is somewhere else. So here's an example of their website. So this is population data, and as you see, it's just a bunch of links. It's really just a big, long list of links. These are Excel files. These are flat files, your CSV files. And it's not all in one place, and it's all very hard to navigate your way into. So regional data was not so strong. Fukushima Prefecture has its own radiation data, but it's also in PDFs. So I thought I'd take a slightly different route. How many people have heard of Safecast? Is there anybody who knows of Safecast? We have one. All right, thank you very much. Maybe you've been to the Nerd Night talk. So Safecast is an amazing group. It's a volunteer group created after the disaster in Fukushima. Their mission is to keep radiation data and open and honest. So they build and sell devices that you can just put on the outside of your car and collect data. And then they provide a very easy interface to go ahead and put it up online, and you can download directly from this API. You can open up a browser right now and get radiation data out without signing up. Just put in some simple search terms. So a quick summary of my data section. So what I used some city locations, some longitude and latitudes that I found on a website, because I wanted to put data on a map of Fukushima, so I needed some locations. I got city populations from that Fukushima website out of some Excel files. And radiation and location data, I knew I could get some JSON data. If you don't know what JSON is, ask me later, from that Safecast API. So I've got my data decided on. Now we need to go ahead and get that data. How many people here know Python? Okay. All right, you probably know more than I do. But okay, so for you Python nerds out there, I am a newcomer to Python. I jumped straight in with the newest version. I believe it's 3.7.
Well done.
Sorry?
Well done.
Oh, all right. So why Python? It's easy to learn, easy to use, and it has loads of libraries. I did not exercise Python to its full extent, but I did use it. So just a quick introduction. It is easy to learn. Syntax is easy to learn. There's simple syntax, fewer brackets and parentheses than other languages, which can get confusing. And also it's white space delineated. Now maybe you don't know what that means exactly, but it means that the program's shape influences how it functions. So usually good programmers will indent things. You see things are slowly moving into the right in my code here. Python actually enforces this. If you do not structure your program visually in a way that the computer can understand, it will not work. So in that sense, the structure of the program and the visual experience of coding is a lot more direct and easy to follow. Python is also easy to use. Here you see a 3-year-old learning Python. I'm sure they're just watching YouTube or something, unfortunately. So there are great tools in Python. Pip is something that you can use to download all of your libraries, which I will talk about in a few seconds. There's also a virtual environment. So if you're doing a lot of different projects and you use a lot of different tools, again, this is a bit complicated to really describe in detail, but there is this awesome tool that keeps your projects separate from each other so there aren't any conflicts. There are also very straightforward ways to read and write files, which are not a given in other languages like JavaScript. And there are built-in data types for analysis. So it's this easy to learn and easy to use sort of aspects of Python that made it very popular. And also it's open source. So in a world where perhaps visualization tools or mathematical analysis tools are very expensive, this is a free platform to build your own thing on top of. And people did exactly that. They built all of these, also open source, libraries. So I brought these two out first. Requests and Beautiful Soup are two very simple Python libraries to get data from the internet and then to parse it and understand what's in it. But people who know a lot more about a lot more about math than me, made all of these amazing things that you can use to do more complicated data analysis, do visualizations straight from your data, and also do machine learning. Later on, we'll have some talks about ML5, which is something based on TensorFlow, which sort of started off in the Python world. But again, lots of modern technologies are being built on and around the Python language. So here we go. So here's what I used. Again, just a quick summary. If you want to get into more details about what I did and exactly how I did it, I'll be happy to talk with you later. But I used requests to get data off the internet, whether that was HTML or an Excel file, or even calling things from the Safecast API. I used Beautiful Soup to sort of sort out the longitudes and latitudes of my city data. And then I used a couple of libraries for getting things out of Excel, and also dealing with some of the eccentricities of Japanese text. If many of you probably know, Japan has full width numbers and half width numbers, and they don't play too well together, especially if you want to treat them as numbers. So that's where I pulled that in on. Okay, so I've got my data, I know how I'm going to get it, and actually I've already gotten it in this story. So here we go. Here is D3.js, which is the library for JavaScript that I used to actually create some of these neat visualizations about Fukushima data. So a quick introduction to D3.js, or D3 I'll call it. It can help make your data come alive in a web page. Graphs, charts, maps, dynamic and interactive visualizations as well. This picture over here on the right is actually just a bunch of different sample visualizations that are on their main website, which is d3js.org. But all amazing. You can just click through. You can see how they created them as well. It's a very informational website, and amazing, really, what you can create with a simple basis of data and some JavaScript code. So what does D3 run on? It runs on the basics of the internet. So of course you've got your HTML, CSS, and JavaScript. Again, sorry to anybody who's not really familiar with all of these terms. If you want to know more, come up to me later. But what it really leverages in a big way is this thing called scalable vector graphics. So scalable vector graphics are rendered by the browser. So you tell the browser, I want a circle, I want it here, and I want it this radius. Now the browser can take that information and render it in a very clean way. If you give a browser a JPEG image or just normal standard image data, as you make that image bigger and bigger, it'll get more and more grainy and look uglier and uglier. Whereas these scalable vector graphics stay clear the whole way. And if I have time, I'll be able to show you a little bit of that in my demonstration later on. So what is D3 actually doing? So there's a lot going on this slide. But basically, you've got your data over here in a big table maybe. And D3 is the go-between, between that data and these elements that I was just talking about. So your SVG is a big list of circles. But where do those circles go? That's where D3 comes in. D3 will map each of your data points to a circle, and it will use scales. to say, take my latitude and longitude data and tell the browser exactly where on the screen that circle should be for, say, Fukushima City or Iwate City. Not Iwate City, Iwaki City, sorry about that. And it also uses CSS. So all this then comes together in your browser to make a magical thing that looks very pretty, and hopefully mine will perform well. So here it is, the moment you've all been waiting for, I hope. Some quick visualizations. All right, so let me zoom in a little bit on this. All right, so what we're looking at is population and population change Fukushima 1999 to 2018. So again, I took off all of those population files, one per year at least was what I sort of pared it down to. And it's a little bit faint, but you can see here I've got circles over each of the major cities and villages in Fukushima. The size of the circle is of course in proportion, or sorry, the area of the circle is in proportion to the population. Just for reference, you have 100,000 population is about this size. And here we have change per year. So since this is the first year, you're not seeing any change yet. But as I move my pointer here over the bottom this year section, I will actually go through time and show you different years of the Fukushima population growth and how that happened. So again, you can, just building this, you can see new things that you maybe wouldn't have seen before and learn things about your data. So this is more about the power of visualizations than maybe the very detailed stuff about how to write D3. But as you can see, Fukushima and Koriyama, sort of in the core area of Fukushima, grew this year. But as you go through the years, you actually find that Fukushima is like a lot of other places in rural Japan that is generally suffering from a shrinking population. Whether it's the elderly who are slowly growing fewer and fewer and not being replaced by younger people. I tried to say that as nice as possible. Or if it's just like people moving out of the countryside and into the city. And you also see some very interesting things here. In 2005, I've got this very green circle right here. That is Aiza Wakamatsu City. Why is all of a sudden, why is Wakamatsu getting very big? And if you go back a year, you'll notice that there's a circle right here, actually. And then if you go to the next year, that circle disappears. So you can also see things like Gappei, which is the how Japanese villages are slowly absorbed into the larger municipalities. So you can see little blips of bright green here and there, where smaller circles are disappearing and that population is moving to the larger city and making it look like that city grew, whereas actually it probably shrunk overall. So I'm just going to zip through a little bit more. 2007, 2008, for those who can't see. For those who can see on the bottom, there's a little red line going through my date. That is the year that the disaster happened in Fukushima. So after this, especially if you go one more year, you will see a lot of red. A lot of people moved out of Fukushima, out of these different areas. And as you continue on, again, generally the trend never gets to sort of where you were seeing some green. It's just, this is I can't quite explain this one. This might have been another year where a lot of cities also grew bigger. But also in this year, you'll notice on the right side of the chart, all of these circles disappeared. These are the circles immediately around the Fukushima reactor. And actually in the data that Fukushima publishes, they showed numbers for a while, and the last few years have just been hyphens. So I don't know if they're not counting or if it's just fully evacuated and they just stopped trying to call that the population of that town. But yeah, it's now being communicated to the public as zero population. So there you go. Here's a quick and simple, the data really isn't that complex, but it's interesting when you get it up onto a screen and see the different trends that you can pick out. So I'm going to go ahead and go to my next visualization. This is very similar. So here you see this is Safecast data. So I did a scan across Fukushima. My scanning wasn't very great because there was just a lot of data, and it would have taken me a long time to get all of it. So it's a little sparse, but here you can see this is the area here on the east coast of Fukushima where the nuclear reactor was, and you see that the radioactivity largely went up into the northwest towards Fukushima City. which you see just to the left of this giant purple peak here. And like the other one, I also animated this one, so you can go through and you see 2012. Again, data is looking a little sparse. I will show you in a moment something with a lot more data on it. But here you go. You can sort of see that the general levels are dropping as you go through time, 2016, 2017, and 2018. And also, maybe as time goes by, Safecast data isn't being measured quite so much as before. So here you go. If anybody's really curious, this is counts per minute data from Safecast. But just another real great way to show, and in this circumstance, it's a 2D data. I'm taking latitude and longitude, but by squishing my image down a little bit and making the bars show up just in the right place, I could make it basically a 3D image. So again, like I said, this data is a little spaced out. I do have much more defined data for this year of 2015 though. So let's go to that. And there you go. If you make a finer scan, you can get a lot more data and see a lot more detail here and there. So, but again, the general theme is the same. You see a huge spike around the reactors and up towards the direction of Fukushima City, whereas Iwaki is not that badly affected in the southeast, and some sort of lingering along the main corridors of the Fukushima prefecture. So that's my demos. Let's just go back for a quick wrap up. Advice and conclusion. I don't know if I can give much advice. It sounds like many of you are very good, hopefully, with Python already. Give me tips, actually. Please talk to me. Python, if you're starting out, learn pip, of course, because that's how you need to get all these great tools like Beautiful Soup and requests. And if you want to go crazy with numbers, go with pandas or NumPy. Also, general Python and library tutorials. I referenced one in my talk when I created that world map, but if you're curious, I can share more with you. And figuring out the soup can be hard, but stick to it. For those of you who have not scraped the web, who have not tried to get data out of websites, it can be a bit difficult, but it's just a game of just trying, sticking to it, and finding those little keys that can help you get that data out. As far as D3.js is concerned, Curran Kelleher, that's the world map guy. His tutorial was really good for getting started on D3.js if you've got a little bit of JavaScript background. And learn what's called the general update pattern. So especially if you're making your D3 visualizations interactive, this is the thing that's going to refresh all of your data. So when data disappears, it removes things from your picture, and as new elements come on, it paints them fresh for you. And also be careful of versions. I found a lot of very interesting examples of D3 on the internet, but when I tried to put them in my environment, they did not work because that just wasn't what it was called anymore. It was a D3 version 2 example, and I was on version 3. So again, very sort of beginner kind of mistakes that I made, but important to be conscious of as you go forward. So that's all for me. I don't know if I'm over time or way under. We're just right?
You have about 10 minutes left.
I have about 10 minutes left. Okay.
You're fine. Yeah.
Well, I did that in 20 minutes? That's amazing.
Approximate.
Yeah, I did. They finished up too. They're going to give up. If anybody has questions right now that they'd like to throw out in front of everybody, I will field them. Yeah.
Okay. When do you actually have experience on deploying these on the web? Do you put the data with the front end files, or do you have them back in the server somewhere?
So if I were to deploy these, they would be, of course, on the back end, but they would probably be sent as a big chunk with the HTML.
Okay.
Yeah, to be delivered. You could make them more dynamic. You could open up a stream or something with WebSockets or something to make them interactive and download in real time. But to put this up immediately right now on Heroku or something like that, it would have to be on the back end and just give them all the data. Anything else? Sorry, I'm so thirsty. That was a new speed record. I probably spoke way too quick. Anybody else? All right, well, I'm happy to answer questions during the free time, so thank you very much for your attention, and enjoy the rest of Big MiniConf. Thank you.
Thank you for coming. My name is Min. I'm from Korea. I like coding because I can create any services if I have a laptop, but it's up to my skills. So I joined Code Crystalist to enhance my engineering skills. Okay, and today I'll be speaking about JavaScript. Specifically, I will why I would choose to use Vue.js and Nuxt on when working on any project. Before starting to take a look at the frameworks, I'd like to explain a bit about JavaScript. And JavaScript history can be divided into pre-Node.js and post-Node.js. Before Node.js was released, the JavaScript ecosystem was really small. It means you had to develop your project from scratch. It takes much time, and after the Node.js created, and the JavaScript ecosystem was completely changed because the many companies and individuals made their own packages public. A great community was created. And this graph shows represent the how many packages each language has. And the JavaScript has over 800,000 packages, which is at least 3 times as many as other languages. And it means that the evolved ecosystem allows developers to code efficiently and easily. Nowadays, there are 3 big frameworks, and I will choose the most suitable for most project after comparing the 3, and everything will be my personal thoughts. So just first one is AngularJS. AngularJS was the first one I ever used, and it was evolutionary for me, who had only used jQuery. So I was really looking forward to the version 2, but the version 2 changed the many features, a lot of the features from version 1. So it felt like a completely different framework. So, and there were many bugs. She was very sick, but now it's become much better. But if you want to use Angular, you need to learn TypeScript and RxJS. So the learning curve is high. And React360 created by Facebook, and they have biggest community. Thanks to the virtual DOM, the rendering speed is very good. So I prefer using the React.js because they always show new features using React, like React Native and React 360. But if you the JSX and the ES6 could be challenging for new users, so the learning curve is high. The last one is Vue.js. Vue.js created by Evan Yu, and the community is smaller than the others, but it is growing at a rapid pace now. So, and it has the most GitHub stars now. And if you want to use Vue, just only you need only basic web and vanilla JavaScript skills, anyone can start to use Vue.js. So the learning curve is very low. So here is the sample component. Left one is React and right one is Vue component. React components only use the JavaScript, and the Vue component has 3 sections, and the template and script and style. It has a very similar structure to HTML, so it is very easy to collaborate with designers and publishers. So yeah, my choice is Vue. So let's make an application. But wait, it has a very critical issue, because front-end frameworks are not friendly with search engine optimization. What is search engine optimization? Search engine like Google, Yahoo use robots or spiders to visit and download a page from your application, and they also extract its links in order to discover additional pages. But if you use just single application, search engine cannot anything from your web application, just show empty text. So your application is not searchable on the internet. If you are going to use the application for intranet, you don't need to care about that, but you usually use web page for public, so it is a very big issue. So I'd like to look more about the rendering. There are 3 ways to render a page. And first one is client-side rendering, and we call it SPA, single page application. Next one is SSR, server-side rendering, and last one is pre-rendering. And I'd like to learn more about SPA and SSR. And this diagram shows how SPA works. And at first, the client creates initial request to server, and server send all HTML, CSS, and JavaScript to clients. And then the clients request the only necessary data to server, so it is very fast. And here is a pros and cons of SPA. It's like a native app, so it's very smooth, and the components are already on the client side, so the rendering is faster than the SSR. And the cons are the first loading can be slow because they have to load HTML, CSS, JavaScript at first. And then, as you know, we show just empty page to users, so it's not SEO friendly. And next one is server-side rendering. Client create a request, and server just render all prepare fully rendered page and pass the page to the client. Very easy. Yeah, the pro is just search engine optimization friendly. That's it. And just they reload the old page when every request, so they have React's problem because at first show white page and then re-render the page. And how okay, and yeah, choosing one is very controversial. So yeah, So Captain America says the multi-page application is better because it is search engine optimization friendly, and Iron Man says the single page application is better because it has better performance, and they could SEO is better, better performance. So they are about to have a civil war, but you don't need to worry about that because we have a solution. The solution is Nuxt. Nuxt can use the SSR and SPA at the same time. And you might be asking me how. First, the Nuxt is a framework for creating Vue.js applications, and it has 3 modes. The first one is universal mode. It is the most important mode because it uses the SSR, SPA, and at first just load the pre-rendered page like multi-page application, and the application becomes SPA and works like that. And I will explain more about very soon. And then next one is static generate mode. It creates a static page for each page. Just pass the HTML page. That's it. And last one is single page application. So I explained the single page application, so I can skip this explanation now. And universal mode run JavaScript code server side and client side. We have just one JavaScript code, but Nuxt run the code 2 times. So we use same code server side and client side. And Nuxt also provide the built-in method Nuxt server init, middleware, validate, async data, a fetch. Oh, sorry. Let's see the example application. This is my just sharing information about BTS, and as you can see, I put the async data and add the console log to check where running the code, and this is production server, and I will reload this page, and you can see I'm on post, and this is the server side, and you cannot see anything from the client side. And and then move to, as I told you, this application becomes a single page application, and move to other pages. Oh, I'm sorry. And then come to post page again. You can see that I'm on post page on the client side. If I move to other page and then again come back to the post page, you can see just on the client side, not on the server side. It is isomorphic application. And this diagram represents how the Nuxt works. If you create a request and the Nuxt runs the Nuxt server init and middleware and validate async data, fetch, and create a fully rendered page and pass the page to client. And client get the page and show the page and change the application to single page application, and then runs the Nuxt run the code from middleware and validate async data, fetch, and render page on the client side. Okay. I would like to introduce the nice things about Nuxt. The first one is louder. Actually, when you use the Vue.js, you have to, when you create a page, you have to set the louder to match the louder and component. But if you use Nuxt, you just create a component in pages folder. Nuxt generate the louder automatically, so it is very convenient. Like index view and test view, like that. You don't need to write the code like right side. And the next one is dynamic page. If you have a dynamic page, just use the underscore, like underscore ID dot view. You can change the contents by depending on the ID, and you will create the path like users / ID, and you can use the page as a dynamic page. And if you want to create nest router, you have to change the ID underscore ID dot view to folder, and create index view, copy the code in the underscore ID dot view to index. It's just same, and create contact view, and for example users ID 1/contact. You can see the target the contact information having the target ID. And next one is validate. Validate can access the parameters, and you can check the validation of the parameter. And if you the validator, the parameter is valid, it will return true. If not, it will return false. And the return value is false. Nuxt redirects to error page. So you can check your parameters validation with validate method. Yeah. In this sample code, just check the number. If you access the page with the string, it will return false and redirect it to error page. And last one is layouts. Layout components make your structure of your application, and if you have the common components like header, side menu, footer, and you save the components in layouts, you can just and your page, all your page load the layouts. And if you want to create a custom layouts, you can also create the custom layouts. And let's see the application again. Okay. Here is the layouts folder. I created default view. It contains the calendar and Tepa, and I created login view login component for login page. Actually, usually components, the page, all page load the default component, but I want to apply the login layout to my login page, so the other page has just all the default layouts, but I added the property in login page, like layout, the layout name, and if I access the login page, there is no calendar and Tepa. So you can manage your layouts. It's like wrapper of your web page. So you can easily manage your web page with layouts. Yeah. In conclusion, you can get the best of the both worlds, SSR and SPA with Nuxt. It was this universal mode, and as I told you, the Vue.js and Nuxt is just needed basic web knowledge and just vanilla JavaScript skills. So it has low learning curve, and as you can see, they provide many convenient features to build your application, so you can save your time and money, and you can build your application very easily. Thank you.
Anything else? Ready? Okay. Hello, everyone.
Hi.
Yeah, hi, how are you? Everyone's doing good? It seems like there's a nice community that's come together here. Everyone's been talking a lot, so it's really great. I'm going to be talking about creating AI game agents today. This is sort of my first time trying to do anything like this. I actually didn't know much about this topic before this presentation, so I'm really excited to share what I've learned over the past few weeks. Before I do that, let me just introduce myself. So my name is Ben Dyer. I'm from Seattle. Has anyone been to Seattle?
Yes.
Anyone else from Seattle? Okay. All right. Yes. Okay. I'm from Seattle. This is. Does anyone know what this is? Good. Okay. Silence. So before I came to Japan, I've been here for about 10 months or 8 months now. Before I came, I was actually doing mathematics. I got my PhD in mathematics. I was studying algebraic geometry. This is a picture of famous picture for algebraic geometers. And after that, I was teaching at a college, and I was teaching mathematics, but I was teaching in the computer science department. And that's when I started doing some programming. I got really interested in it and decided to make a career change. So that's kind of what brought me here. That's why I joined Code Chrysalis. Yeah, so I've got some information here. You can connect with me. I'll put it back at the end. But let's get started. Disclaimer. So you should know I do have a PhD in math, okay, but it's not a PhD in machine learning or anything like that. So I'm not an expert. So please just be aware of that. This talk is going to be kind of introductory. So if you're like me, machine learning is new for you. Hopefully you can see an interesting way of getting started making games. So I'll also talk about some history. So let's just talk about some background information. AI in games. So first of all, what is AI? What is AI? When I hear AI, I think of this picture, which is funny to me because I don't really know what this is a picture of. So maybe you're like me, maybe you think of something like this. But actually AI is not just one thing, it's a bunch of things, right? So here's some examples: facial recognition software in Facebook, Google self-driving car, and the list goes on. So I'm sure you already know plenty of examples of AI, but here's just a quick list. Moving on to games, does anyone know when this picture was taken? No? This picture was taken in 1997. On the left, we have Garry Kasparov, then the world champion of chess. And on the right, we have the man representing Deep Blue. Deep Blue was a chess program. It was the best chess program available at that time in 1997, and it was totally rule-based. Okay, a bunch of people who knew a lot about chess got together and wrote an amazing program to play chess. And this is actually the rematch. 1997, the rematch. Garry had won the previous match, but he lost this one. He would go on to lose this match 3.5 to 2.5. So that was kind of the first time, I think, that in a game like this, that humans were beaten. Moving to the present, I'm going to talk about some technology by DeepMind and OpenAI that I think is really interesting and exciting. So I'm sure you've heard a bit about Alpha. It was mentioned in the previous talk as well. So here's a picture of Lee playing Go in 2016, and he did lose this match 4-1. So this was the first, this was an example of an AI agent beating humans at a complicated game. So in this case, AlphaGo was actually an AI agent. And in 2017, DeepMind announced further technology. AlphaZero actually plays all 3 of these games. It can learn all 3 of them. And what's really cool is you don't give it any information to start with. Unlike AlphaGo, they actually fed it a bunch of example Go games, but AlphaZero, not the case. AlphaZero starts with nothing, and it learns to play these games in a very short period of time. So it's really amazing. Sorry, clicker. Yeah, so this is the test of AlphaZero. I played the current best chess agent, which is Stockfish. Yeah, in a game of computer versus computer. And AlphaZero won like really strongly. 28 wins, 72 ties, 0 losses. I think that's amazing. So this game just learned in 4 hours how to play chess by playing itself, and it destroyed this engine that tons of really smart people came together to build, a rule-based agent, Stockfish. Yeah, so I thought that was really interesting. It's part of the reason why I wanted to learn more about this topic. Here's a quick, just little thing from the AlphaZero's website, so you can see how long it takes for that. First example is chess, and they're showing shogi and go. So this is how many training steps, how many games does it have to play in order to actually learn this information. So it is actually quite a lot. In 4 hours, it plays a lot of chess. Okay, yeah, so that's kind of the state of the art with chess. So I want to talk about how does that happen? How did they learn how to play chess in such a short period of time? Okay, how does an AI learn to do this? Of course, the answer is machine learning. And as was mentioned in the previous talk, if you were there, there's 3 different regimes of machine learning. So here's a nice visualization of that. I'll just put some images around here before we look. Okay, laser's not working, but supervised, reinforcement, and unsupervised. So in the supervised category, that's where facial recognition is. In the unsupervised category, recommender systems. Okay? And if we move to the reinforcement learning, this is where robot navigation, task learning, and game AI fits. So this talk's going to only talk about reinforcement learning. I think that the sort of, I don't know, the most common examples, the first example I heard of was like image classification, and that's kind of a totally different situation. You need to give it a bunch of data, and it will observe that data and learn how to predict something. But reinforcement learning is quite different. Okay, so let's talk about the basics. So, no data. That's pretty cool. So what is there? There's an environment. The environment provides some information. It provides, you can think of it as kind of the rules of the game. So that's information is contained in observations and actions, and also provides rewards. And so once you have an environment, then an agent can kind of explore that game, and as it receives rewards, it'll update its behavior. Okay? So let me explain this with a diagram. All right, so there's an environment. It has some actions. First thing that happens is the agent makes an observation. So maybe it can't see everything. If it's chess, it can just see the whole board, but in some games, you might not be able to see all the information. So the observation gets passed to the agent, and the agent picks some action. Okay, so the agent will choose some action based on the observation and whatever its data is about decision that it's storing. The environment will generate some kind of reward. It'll hand that over. And then what happens? The agent updates its information. Okay? So I'm just going to go through that again and point out the main things we need to pay attention to. This step right here. How does the agent choose what to do? That's important. Okay, and the reward, okay, that reward's actually quite important too. But the other thing I want to point out is, how does it know how to update the data? That's another really important part. How does that work? Okay, so we need to figure that out. All right, so let's look at an example. So tic-tac-toe, simple example. We should be able to describe what the environment and everything looks like for that. Just some practice with the terminology. So, what's an observation look like? Well, it's just what I see on the board. Okay, the observation. Okay, so there's 9 squares, there's 3 possible answers. It could be blank, it could be circle, it could be X. Okay, so that's what an observation will look like. There's a bunch of possible observations. What about an action? Well, there's just 9 squares to choose from. I can't do much in tic-tac-toe, so there's only 9 actions. Okay, and what about rewards? Well, for a given game, you have to choose the rewards. You have to design this somehow. This game's so simple, probably you're going to choose, okay, +1 if you win, -1 if you lose. If it's a move that doesn't end the game, 0. Something like that. Okay, that's just a simple example. I actually haven't implemented this or tried this at all. So yeah, take that with a grain of salt. But basically, I think we can sort of understand the terminology that's going on here from this. Okay, so let's talk about how does the agent learn. That was that spinning part. How do we update things? So a technique is queue learning. So we're going to talk about how queue learning works. So first of all, what is the decision data that this agent's carrying? Okay, what is that? It's going to just be a table. It's called a queue table. And the dimensions are observations, all the possible observations you could get. So that's this really big number, an example of tic-tac-toe. And all the actions. So observations by actions. And in this table, we're basically, in this table, we're basically going to store one number in each cell. And that number is going to determine how good we think that action is given that observation. So how I'll use this table is if I'm playing the game, environment gives me an observation, I'll just look in the table, look at all the actions, which one's best, and I'll pick the one with the largest value. Okay? There's a little star next to that because while you're training the algorithm, you might get some bad ideas at first and you want to experiment more. You want your agent to be able to explore, so you should actually sometimes just make a random move. You should try out all the different moves you can do. Okay, so that's a little asterisk. You need to add that into your programming. Okay, and how do you actually get this queue table updated? Well, start with just zeros, or actually you might want to I think I randomized it, so yeah. Won't speak more about that, but so when an action is made, a reward is received, update. How do you update? Well, there's an equation for that. So they said that I shouldn't probably talk too much about math, but I can't help it. I'm a mathematician, so I'm just, bam. Okay? So this actually is not the really super theoretical Venn equation. I spared you from that. This is actually an assignment statement. If you're a developer, that's assignment equality. So you just take your queue value and you set it equal to this. Well, what's all of that stuff? S, A, and R are just state, action, and reward, like we've already been talking about. So that part should be straightforward. What's left are hyperparameters. Learning rate and discount factor. So, okay, maybe that sounds confusing, hyperparameters, but really it's just some numbers that help you tune your algorithm. Learning rate is how fast do you want to learn. I mean, you can see if you plug in 1, the left term goes away and you're learning quite quickly. If you plug in alpha equals 0, you're doing nothing, so no learning. Okay, so that's the basic idea. You don't want to learn too fast sometimes because the algorithm might not work. Okay, so takeaway. Using the Bellman equation is really easy. It's just a single line of code. So it's actually quite simple. All right, is it really that easy though? No, the answer is probably no. Okay, clicker's not working. There we go, no. For a more advanced game, you're gonna wanna use something like a neural network and incorporate that in. I don't wanna talk too much about that in detail because, I don't know, if you haven't heard of neural network, then you're probably not gonna understand anyways, and if you already have, well, okay. I actually haven't used any neural networks in the example I'm going to show you, but I'll talk slightly more about them later. Alright, so this slide means it's time to talk about an example where I built an algorithm to solve a game. So this game is from OpenAI Gym. If anyone's heard of OpenAI Gym, it's actually a really, really nice thing. You should check it out if you're interested in doing machine learning. It provides a bunch of environments and you can just play. You can play with all these different games and try to build your algorithms. And there's lots of there's lots of people to talk to. There's a nice community about it as well. So this game is a taxi game. The yellow square represents a taxi and is going to pick a passenger up at the blue R and drop them off at the G in the right corner. And when it turns green, that means it's picked up the passenger. It's a full taxi. Okay. So that's the game. You need to train AI to do this task. And you can do it with queue learning. So, how does that work? Well, observation space. Okay, there's 25 places where the taxi could be. It's a 5 by 5 grid. In this particular example, the passenger only is going to be in 5 different places, and there's only 4 different destinations that we're working with. So it's actually a pretty small number of observations. And the actions are pretty small too. There's only 6 of them. You can move in any direction, or you can try to pick up or try to drop off. So 6 actions. That's quite small. Our queue table is just by 6 by 500. That's not too bad at all. All right, what about the rewards? That's the complicated part. So in this case, rewards are already determined in the environment. We don't have to choose them ourselves. It's 20 if you win. If you successfully pick up and drop off, then that's 20, so a huge reward. If you incorrectly drop off, that's pretty bad. So we want to give a large negative number for that. And we don't want the taxi to drive up and around and take an inefficient route, so every time it moves, actually every time it takes an action, we deduct 1 from the reward. So that's just the design of this environment. Now you have to write your algorithm. Okay, so we wrote an algorithm using exactly what I said before. I don't know much about hyperparameter tuning yet, so I just picked a couple of values, and after 500 times, agent already wins 85% of the time, after 500 training steps playing the game. So I thought that was really cool. It was exciting to get something working. I want to encourage everyone who hasn't done much AI before to try something like this. It's really cool, and you don't need a source of data at all to do it. So it's reinforcement learning. Okay, so now I want to transition to the next part of the talk, where I want to talk about some things that I'm really interested in doing in the future and what I'm working on now. But first, let me just talk about what games can AI play. Can AI play any game? So we know it can play chess, shogi, and Go. It can also play some video games. Recently, it can play Dota and StarCraft. This is like work by OpenAI and DeepMind, so that's pretty cool. A big difference with this is there's a huge number of actions that you could choose from. It's like a really huge number. And it's also a situation where you don't have complete information. If I'm on one team, I can't see everything. I can't see where all of your players are, because that would be weird. Okay, does anyone recognize this? You do? Okay, great. What is it? All right, awesome. So someone already knows what's going on. That's great. So another really interesting section of research is work on Atari 2600, which you'd think would be easier, but actually it's kind of hard. So for example, here we have this game called Montezuma's Revenge. You have to collect the key and get to the other side and all of that. So what makes it hard is something called sparse rewards. It's hard to figure out what reward to give. So for example, what do you do? What do you give a reward only when you get the key? This guy's never going to figure out how to get to the key. So you got to put another reward in there somewhere. What, when he enters a ladder or something? Okay, now you're just basically designing the algorithm without machine learning if you start doing that. So it's hard to figure out a good adaptable reward function. And the game that I'm really most excited about that got me interested in this project is a game called Hanabi. So I'm actually not really a gamer. I don't play chess at all, but this is a game I love to play. So that really inspired me when I started thinking about Hanabi as a game. So I did a quick Google search and I suddenly found that this game is being called the frontier of AI. So that's really exciting to me. What is Hanabi? Does anybody know the game Hanabi already? One person. Have you played?
I never played.
You've
but
never
I know
played.
the game. I know how it works.
We should definitely play, because I have the game. Okay, but anyways.
You can play later.
Okay, yes. Alright, so the rest of you don't know what Hanabi is, so I'll just quickly explain and then tell you why it's interesting for AI and how you can get started trying to work on it if you're interested. So Hanabi is a cooperative game. That's a little different than things we've seen before. And it's a game about communication. It's also a card game. You can notice some cards in that picture there. So the gameplay, it's a little bit similar to Solitaire in the sense that there's a bunch of suits. You're stacking cards up from 1 to the top, which is 5. The big difference is you're working together on a team, and there's also a catch. You cannot see your cards. Okay, you cannot see your cards at all. You have to give hints to your teammates, but you can't just say the thing you want to say, like play this card, please. You can't say that. You can only say what all of the cards are that are of a given color or of a given number. So for this hand, I could say you have 2 1s and say where they are. Or I could say you have 2 red cards, these ones, or 2 blue cards, or 1 green card, 1 3, that type of thing. So it's hard to communicate, but that's what makes it really interesting. So the thing that's cool about this for challenges for AI is that it's a cooperative game. That makes things really different. Incomplete information. This is really extreme in Hanabi, so this is really cool. And the last thing is there's different playing styles. If you start playing Hanabi, you'll realize that different people play in different ways. So that's actually, yeah, I think people are not even trying to work on that part yet. But moving into the next section, DeepMind has released something called Hanabi Learning Environment. Hanabi Learning Environment is basically an open source environment, written in Python and C++, but you can just ignore all of the C++, you don't have to worry about that. So if you can write in Python already, you can start looking at this, this repository on GitHub and yeah, try to use it to start writing some Hanabi machine learning algorithms. That's something I'm working on now, but haven't had enough time to really get anywhere with it. So what is it? Yeah, it's written in Python, but it uses TensorFlow primarily. It also uses Dopamine. Dopamine is another Google framework that is specifically for Q-learning, but deep Q-learning. So once you combine neural networks into the strategy and you use deep neural networks, that's a helpful framework to have. It also provides just a basic DQN, a basic neural network agent that is built with Dopamine, and an even sort of more special agent called the Rainbow agent. So it provides their idea for what's a great algorithm for Hanabi, but there's still quite a lot of work to be done. So they provide some data. I won't go into it too quickly, but you can see in the top there's some rule-based bots, and over here in the numbers, 25 would be like a perfect score, so it's showing average score. And then the percentage is the percentage of the time that you get everything. You get all 25 cards laid down. So as you can see over here in the, these are the actual sort of bots that were made with machine learning. They struggle in a lot of areas, like with more players, it's quite difficult. Trying to get a perfect win is quite difficult. They only have it in the 2-player case. Yeah, so I think this is just a really exciting piece of information. It just makes me want to try to write an algorithm. I don't know about you, but when I see this, I want to try to work on that. So I hope that inspires you. So I'd like to wrap things up here. Basically, so my takeaways from this are reinforcement learning is a really nice way to get involved with machine learning if you haven't done it before. You don't need to search through the whole internet trying to find a database that you want to use that is interesting and amenable to the machine learning algorithm you're trying to work on with now. You can just jump right in. So I think it's a really cool way to get started. I recommend OpenAI Gym. It was really easy to work with that. And also, Hanabi is super exciting. If anyone else is interested in working on that, please talk to me. I'd love to have someone to talk to about that. So I'll end it there. Thank you so much. Here's my information. Let's connect. All right. Thank you so much.
All right. See you, everybody.